What in the heck is up, guys? It's Jacob here, and welcome to your fourth Arduino tutorial. Today we're going to be talking about if and else statements. These are again just very basic structures for Arduino, but very essential. So again, it's just very beginner basic stuff, but you'll use this a lot. So this is again aiming towards very beginning users, but even if you are an advanced user and you have used if statements for a while, you may not know all six comparative operators. So keep watching. But there's lots of cool stuff that you can do with an if statement. So let's go ahead and explain the if statement. It's very simple, but it's very useful and you use it a lot. Um, let's go ahead and just stick with our basic code that we've been using for a while, the pin 13 LED, just because it's an easy one to use. Again, this is just a very basic use of an if statement, but it shows exactly what it does. So let's say int LED equals 13. So this is going to set that, again, that LED to 13. So now what we're going to do is, in our void setup, we're going to go ahead and make a, I don't even know what the hell we're going to do anymore. What are we going to do? Pin mode, and then we're going to say LED, and we're going to put it as an output. So that's going to make it an output. And then for our loop, what we're going to do is we're going to put our if statement in here, and I'll show you guys what that does. So before we make our if statement, let's go ahead and make a few more integers. Let's go ahead and make an integer. Let's call this one A. So we're going to call it A. Let's make this guy equal to, I don't know, 2. And then let's make another integer, int B. And let's make this guy equal to 5. All right. So now we have two integers, a and b. A is equal to 2, b is equal to 5. So now what we'll do is we'll have our if statement. Let's type up our if statement. So if you guys have never seen an if statement, this is the structure for it. By the way, guys, I haven't really been teaching all the structure of like a code for this, but this is a lot of it's basic, like C++. But if you haven't ever typed code before, you will start to catch on. Like, you have to have a semicolon after every line to terminate it. You have, brackets around your functions, and then your arguments goes inside there. You'll start to catch on to things like that as you see me type code, and as you type it for yourself. The compiler will highlight your errors, which is always good, and you'll start to see, the syntax and how everything is laid out. But for now, just keep watching these videos. I'm going to explain the exact structure of an if statement, but you guys will start to catch on to lots of things like these braces and stuff and where you do and don't need them. But for an if statement, what you do is you just type the keyword if. So you have the keyword if, and then you have a little parenthesis, an open parenthesis. And what you do is you just type your argument in here. So let's just say something simple. Basically you have two things that you're comparing, and you can compare them different ways. So let's use A and B. Okay, so we're comparing A to B. Now there's a few different ways we can compare A to B. We can say if A is greater than B, if A is less than B. We can say if A is equal to B, greater than, or I'm sorry, less than or equal to, and greater than or equal to. We can also say not equal to B. So let's kind of take a look at all these real quick. So we're going to have our closing bracket, of course, so we have our two values here. And then we have an open curly brace and a closing curly brace, and our code goes inside here. Okay, so we have two things that we're comparing. This is our test, and then if our test is true, we're going to run a piece of code inside this statement. So let's just go ahead and write that real quick. We're going to go ahead and digital write, oh my gosh, and we're going to write LED high. So if this test is true, we're going to turn the LED on, okay? Now, the else part of the statement is what code runs if the test is false. So let me show you guys this real quick. So we're going to go ahead and type else. And then we're going to have a curly bracket. Again, there's no argument for else. You're not going to have any tests that you run. This is what happens if this test fails. This is the code that runs. So we're just going to kind of, for the sake of laziness, copy that, paste that there. And then what we'll do is we'll write low. So now here's what we have. Let me kind of run over this whole thing one more time. So we have an if statement with two little parentheses, and inside the parentheses is our test. Now this isn't the complete test. You'll have a comparative operator in here. I'm going to show you guys each one of those in just a second. Then you have your curly braces right here. These inside the first set of curly braces, this is your true code. So if this test is true, if it passes, then this code runs inside here. And you can have any amount of code you want here. You can have it run just something like this, where it just turns an LED on, or you can have it run a whole set of instructions and do a totally like different type of calculation or whatever. You can launch an ICBM from your iPhone if you wanted to. You can put any type of code you want in here. And then for your else statement, this is what runs if the code is false, or if the test is false. So if this is false, your else statement will run. You do not have to have an else statement. You can totally just leave out the else statement, and if this test is false, it just continues on with the rest of the code. But if you want it to run a different set of instructions if the test is false, then you leave your else statement just like this. So what we want it to do is turn the LED on if this is true, and turn it off if it's false. So let's go ahead and look at each comparative operator. So we have the greater than sign. Now, obviously, in most circumstances where you will use an if statement, you won't have it like this. You won't be comparing two, set integers. You're usually variables that change. So you usually be testing like, okay, if there's an input detected on pin 4, if pin 4 is at 5 volts, then turn something on or run this set of instructions, or, do something. You're not just going to compare two things like this. So you can say if, a lot of times you'll say like this, if equals 1, and you'll be testing a digital pin. So if, let's just say pin 4 like this equals 1. So this means if pin 4 is on an on state, you'll test it. That's usually what you would use this code for, something like this. But we'll use that in future videos. I'll show you guys how this can be useful, but this is just going to show you how it works. That's what this video is for. But so what we have is, if we'll use the less than sign. So let's check this out. Let's take a look at this. For the less than, we're seeing if A is less than B. So A is equal to 2 and B is equal to 5. So this statement is true. A is in fact less than B. 2 is less than 5. Okay, so the statement is true. So if we go ahead and we verify this and upload it and compile it to our board, and then we run this code and we look at it, this is what would happen. Okay, so we can see that the LED turns on because the test is true. Okay, so now let's go ahead and take a look at if A is greater than B. So if we look at if A is greater than B, and we compiled this sketch and we uploaded it to our board, we would get the LED would turn off. Now we can see that the LED is off because A is in fact less than B, but we're testing if A is greater than B. We can see here that A is not greater than B. A is less than B. 2 is less than 5. So this test is false, which means that that is not going to work. So now let's see if A is equal to B. Now, this is one thing I didn't explain yet, is when we do the equals comparator, we use two equal signs. Why do we use two equal signs? You're going, what the hell is this crap? Why don't we just say equals? Well, because up here, let's take a look at this. A is equal to 2. Okay, we're setting this integer to a value using the equal sign. So the single equal sign sets a value to a variable. That's what we have the single equal sign for. So we can't use an equal sign to compare two things. When we're comparing two things, we always use equals because the single equal sign assigns a variable to a variable. It sets a value to a variable. That's what the single equal sign is for. So when we have two equal signs, that means we're comparing something. So if A is equal to B, then this test is going to be true. But 2 is not equal to 5. 2 is not equal to 5. A is not equal to B. So this test is actually false. So if we uploaded this to our board, we can see that when we run this test, the LED is actually off. That is because the digital write LED low is ran because A is not equal to B. So this test is false. So we're using our else statement, and the LED is off. So the one other thing we have is not equals. So we can use, for this we use exclamation point equals. The exclamation point means not. So if this is not, if A is not equal to B, then digital write LED pin 13 high. So in this case, 2 is not equal to 5. And so this test would be true. And it would digital write the LED high. So if we ran this sketch, we can see that the board does show pin 13 high. That's because the test is true. So because the test is true, the LED turns on. Okay, so there's a couple more that are pretty self-explanatory, but we'll just go ahead and go over them. There's less than or equal to. So what this means is if either of these are true, if A is less than or equal to, so it can be equal to, so they can be equal or less than. So A is less than B, so the test is going to be true. 2 is less than 5. So in this case, if we go ahead and run it, we can see that the pin 13 is actually turned on. That's because the test is true. So we actually turn digital write pin 13 high because A is less than B. It can be less than or equal to. So if they were both the same, if both values were the same, if A was equal to B, this would also be true. So let's go ahead and take a look at the last one, that is if greater than or equal to. So if A is greater than or equal to B, then this test is true. So let's go ahead and take a look at this. We run it, and the LED is actually off in this case. That is because we can see, if we look at this one more time, A is not equal to B. Okay, A is not equal to or greater than B. A is 2 and B is 5. So A is less than B and it's not equal to B. So it's not greater than or equal to. So this test would be false, which means it would run our else statement and turn the LED off. So that's pretty much it for if statements. That's a very, very simple if statement. Again, these are very, very useful in all codes. I mean, pretty much any code you write is going to have this. These are used a lot to determine, the state of digital inputs and to set digital outputs. You use if statements and a lot. So these are very, very common. They're a very crucial part of the code. You have to understand these. They're very essential to almost any code, and very simple. So this is just a very simple use of it. Again, there's a lot more useful things you can do with an if statement besides just this, but this is just a really easy example to show you guys how they work. So that's pretty much it for this one, guys. If you guys have any more questions, head on over to my website, thehackhub.com, and you can ask me any questions there on the forum, or someone else could probably answer your questions. Either way, you'll get a quick response. So I hope you guys enjoyed this quick little tutorial of if-else statements, and hope to see you guys in the next video. And like always, guys, have a good one.